Welcome to Simple Statistics. Today we are going to focus about the concept of binary logistic regression using SPSS. It is very important topic in statistics. So let us discuss in a natural manner. The concept of binary logistic regression. The regression technique is used to assess the strength of a relationship between one dependent and independent variables. It helps in predicting the value of a dependent variable from one or more independent variables. Regression analysis helps in predicting how much variance is being accounted for in a single response. That means dependent variable by a set of independent variables. Linear regression analysis requires the outcome or criterion variable to be measured as a continuous variable. However, there may be a situation when the researcher would like to predict an outcome that is very important thing, that is dichotomous or binary. In such a situation, the research scholar can use binary logistic regression to assess the impact of one or more predictor variables on the outcomes. Logistic regression analysis is a method to determine the reason-result relationship of independent variables with the dependent variables. The logistic regression predicts group membership. There are three important points. Predicts group membership. Since logistic regression calculates the probability of success over the probability of failure, the results of the analysis are in the form of an odds ratio. Logistic regression determines the impact of multiple independent variables presented simultaneously to predict membership of one or other of the two dependent variable categories. In logistic regression, the expected outcome is represented by 1 while other is coded as 0. Let us discuss few examples of binary logistic regression. A scholar may utilize binary logistic regression in the following situations. A store would like to assess factors that lead to return or no return of the customer. A college would like to assess admit or do not admit of a student based on age, grade, aptitude test result. Assess if a particular candidate wins or loses an election based on the time spent in constituency, previously elected, number of issues resolved. A HR researcher would like to ascertain how factors like experience, year of education, previous salary, university ranking affect the selection of a candidate in a job interview. A scholar would like to predict the choice of bank, either public sector bank or private sector bank, based on independent variables that include technology, interest rates, value ordered service, perceived risk, reputation, and others. Next important point, let us discuss a few assumptions. Logistic regression does not assume a linear relationship between the dependent and independent variables. The independent variables need not to be interval, normally distributed, nor linearly related or of equal variance within each group. Homozygosity is not required. The error terms, residuals do not need to be normally distributed. The dependent variable in logistic regression is not measured on an interval or ratio scale. The dependent variable must be dichotomous, that means two categories for the binary logistic regression. The categories, that means groups, as a dependent variable must be mutually exclusive and exhaustive. A case can only be one group and every case must be a member of one of the groups. Larger samples are needed than for linear regression because maximum coefficient using a ML method or large sample estimate. A minimum of 50 cases per predictor is recommended according to field in 2013. Holmser, Lemshaw and Stuyvesant in 2013 suggest that a minimum sample of 10 observations per independent variable in the model, but caution that 20 observations per variable should be sought if possible. Here I have shown the data view of SPSS, gender, age, study habits, life facility, campus interview, choice and everything. So we have to go to analyze, then regression, then binary logistic. Then one small pop-up box it will come, it will open. So you put the dependent variable, choice of the college, that is the dependent variable, and the rest of the variable you put in covariates. Then move to categorical. Then from covariates to categorical covariates, you have to shift all the variables to here. Then give continue. The next options, you have to go, you have to click it options. In options, Hosmer, Lemshaw goodness of fit, you click it and you have to click save of expectation beta 95%. Just both, I mean Hosmer, Lemshaw and CI for expectation beta value 95%. You have to click it, give continue. Then output will come. I will show the output later. Here when out will come, case process summary and encoding. Here logistic regression, case processing summary, selected cases 264 cases we have selected. There is no missing value. You see the first section of the output shows the case processing summary, highlighting the cases included in the analysis. In this example, we have the total of 264 respondents. Then dependent variable encoding, preference in private colleges as put 0 and preference in government college 1. The dependent variable encoding table shows the coding for the criterion variable. In this case, those who will choose private colleges are classified as 0, while those who will not choose private colleges are classified as 1. That means government college 1. So next one is block 0 beginning block classification table. The next section of the output headed block 0 is the result of the analysis without any of our independent variable used in the model. This will serve as a baseline later for comparing the model with our predictor variables included. Here you see nearly 59.1% they have selected private colleges. Variables in the equation, in general the block is not usable as there are no predictor in the model. So goodness of fit statistics help you determine whether the model adequately describes the data. An omnibus test of the model coefficient is used to test the model of fit. If the model is significant, this shows that there is a significant improvement in fit as compared to the null model. Hence, the model is showing a good of it. You see here all the values are significant. All the value. The model is also significant. So if it is significant, there is a significant improvement. So the model is good of fit. Next one, in model summary, Cox and Snell R square value is 0.600, and in case of Nagalgarke R square value is 0.808, which is higher than the significant value of 0.05. So later, next table you will see the Hosmer and Lemshow test also test of the model fit. The Hosmer and Lemshow statistic indicate a poor fit if the significant value is less than 0.05. Here the model adequately fits the data, hence there is no difference between the observed and predicted model. The significance value you see 0.914, which is higher than the 0.05. So Hosmer and Lemshow test, based on the test, we can able to understand that there is no significant difference between observed and predicted model. Next one is contingency table for Hosmer and Lemshow test. The model adequately fits the data. As we can see, there is no difference between observed and predicted model. Both the values are approximately equal. You see this value also 0, 0, 0, 0, nearly 0, nearly 1, 6, 3.4, 8, 8, 15, 15, 23, 22, 26, 26, 30, 30. So more or less same value. So observed and value and expected value both are same more or less. Next one is model summary. As already we have discussed the model summary. The model summary shows the very important area, because already in the Cox model we have discussed Nagalgarke square also we have discussed. Very important thing is that the calculation is regression model. When we are doing the research in regression, the model summary is very, very important. The model summary already we have discussed in two ways. One is Cox and Snell R square. Next one is Nagalgarke R square. Nagalgarke R square is very, very important. Here the model summary shows the pseudo square. Pseudo means that it does not technically explain the variation, but they can be used as approximate variations in the criterion variable. Normally used is Nagalgarke's R square. Here R square is 0.808. That means 80.8%. There is a relationship, which is an adjusted version of the Cox and Snell R square that adjusts the scale of the statistic to cover the full range from 0 to 1. 0 to 1. Here 0.6. In this case, we can say that 80.8% change in the criterion variable can be accounted for by the predictor variable in the model. So Nagalgarke's R square, you have to see 80.8%. 80.8% change the criterion variable. Next one is classification table. In the classification table provides an indication of how well the model is able to predict the correct category. Once the predictors are ordered into the study, we can compare this with the classification table shown for plot 0 to see how much improvement is there when the predictor variables are included in the model. The model is correctly classified 89.4% of the cases overall, sometimes referred as the percentage accuracy in classification, PAC. Percentage accuracy in classification, that is called PAC. In other words, this is the rate of correct classification if we always predict that a respondent would choose a private college. Specifically, it presents information on the degree to which the observed outcomes are predicted by your model. So this is a very important thing. The classification table further it shows that the percentage in the first two rows provide the information regarding the specificity and sensitivity of the model in terms of the predicting group membership on the dependent variable. The specificity, also called a true negative rate, refers to the percentage of cases observed to fall into the non-target or reference category. For example, those who will not select private college who were correctly predicted by the model to fall into that group. For example, predicted not to be select private college. The specificity for the model is 91.7%. Here you see this percentage. Overall, the accuracy rate was very good at 89.4%. The model exhibits good sensitivity since among those persons who will choose private colleges over government colleges, 91.7% were correctly predicted to choose private colleges based on the model. The variables in the equation. Odds is the ratio of probability P A divided by probability B. Probability A divided by probability B. This table shows the relationship between the predictors and the outcome. The beta, alpha beta, probability alpha, probability beta. Beta is predicted change in log odds for 1 unit change in the predictor. There is expendable, beta changes in the probability of the outcome. The beta coefficients can change anything, but the beta coefficients can be negative or positive and have a t value and significance of the t values associated with each. This important thing about the confidence interval is that it does not cross 1. Both the values are greater than 1. This is important because values are greater than 1 mean that as the predictor variables increases, so the odds of, in this case, selecting private colleges. Values less than 1 mean the opposite, as the predictor increases, the odds of selecting private colleges decreases. So odds ratio 1. The probability of failing into the target group is equal to probability of falling into the non-target group. Odds ratio greater than 1. Probability of event occurring. The probability of falling into the target group is greater than to the probability of falling into the non-target group. The event is likely to occur. Odds ratio less than 1. Probability of event occurring decreases. The probability of falling into the target group is less than to the 1 or less than to the probability of falling into the non-target group. The event is unlikely to occur. We can say that odds of students preferring to join private colleges, the private colleges are giving campus interview training 20.573. Here you see my cursor is showing 20.773 times higher than those government colleges, which do not offer campus interview training with at 95% of level, significance 0.05 level. Here see that value, CI value 0 from 0.0824 to 806.067. So this is the model. Thank you very much. Let us discuss how we are going to enter the data Let us discuss. Now go to analyze in SPSS model. Then regression, we have to go to regression. Then binary logistic one, and just you have to click choice of the college. You put it in the dependent variable. Rest of the variables you select all the variables and put it here. And categorical, you first go click it categorical and select all the variables and put it here. Continue. Then go to option button, select option. The Hosmer show goodness of it, you click it. Then say up for beta value 95%, you click it, give continue. And method, so many methods are there. Forward method also better, but you just enter method only, give OK. This output will come, case process summary, dependent variable encoding. So this is not necessary for us. Further calculation we can able to. Block 0, beginning block, this one very important, already we have discussed this matter. Variables in the equation, variables not in the equation. Suppose in these variables not in the equation, here that value is, then method, enter method, then omnibus test of model coefficient, all values are significant. The Nagelkerke square, which is more than 0.05, that is the model is fit, we can able to understand. Then here also observed values 0, 0, nearly the same value it is coming. 6, 3, 8, 8, 15, 15, 23, 22.76, 26, 26, 30, like that. Nearly the value has come. Then classification table, then variables in the equation. Here only we have to see campus interview, very important, the campus interview, which one is very highest value, we can able to understand this model. So campus interview, this is 25, this is highest here. So 0.0824, 806.067, this is value we have taken. So this model of it is good, it's enough. So thank you very much.